Assalamu alaikum. Hope all of you are fine and safe. Today we are going to learn the numerical of the chapter number 3, which is spherical, mirror and lenses. Let's move towards the first numerical. Here we have our first one numerical, and what is the first one numerical? The numerical is an object is placed at a distance of 10 centimeter from a concave mirror. So if the radius of a curvature of concave mirror is 15 centimeter, determine the position, nature and magnification of image. There is an image in front of you in which you can see a concave mirror, and plus you can see an object, and after that a image. Let's move towards the data. So in our data, the first one thing that we know about it is distance from the mirror, which is P is equal to 10 centimeter, means the distance between the object and a concave mirror is 10 centimeter. So what is the radius of curvature? Radius of curvature, which is C, it is equal to 15 centimeter. Let's move towards the next one. It is focal length of a mirror. So what is the focal length of a mirror? It is F, and how we are going to find out it is because it is not shown in our data, so that's why we are going to find out it. C upon 2, and what is C? The radius of curvature, which is 15, divide with 2, so we get 7.5. Okay, so let's move towards the next one. It is the position of image, which is Q. We don't know about this. And what is the nature of an image? We don't know. And what is the magnification? Yes, we don't know about this also. Let's move towards the solution. In the solution, we are going to use the mirror formula. And what is the mirror formula? Mirror formula is 1 upon F is equal to 1 upon P plus 1 upon Q. So when we put all the values, then we get 1 upon 7.5 equal to 1 upon 10 plus 1 upon Q. What is the next step? The next step is that we are not aware about the Q, so that's why we will we just work with the non-values, and the non-value is P and F. So the value of P is in front of you, F is in front of you, it is 1 upon 7.5, and it will be minus because the places change of the value, so that's why it will minus it. 1 upon 10 is the value of a P. Okay, so when we solve this, then what we get? We get 10 minus 10.5 upon 75, and just 10 minus 7.5, then we get 2.5 upon 75. Okay, so the numerator and denominator are going to change, then we get Q is equal to 75 upon 2.5, and then when we divide them, then we get 30 centimeters. So it's mean the image is real, or the image will be a real. So let's move towards the magnification. For the magnification, we have a formula which is M equal to Q upon P. Okay, so we have the value of Q just in front of you, 30 centimeter, and the value of P, we already know about this, it is 10 centimeter. When we divide them, then we get 3. It means the image is greater. Here we are going to start with the next one numerical. It is a lighted candle is placed 12 centimeter from the concave mirror. If the focal length of the mirror is 15 centimeter and height of a candle is 4.5 centimeter, find the position, nature and size of the image. Let's move towards the this is the picture of all the numerical, that there is a lighted candle which is placed in front of convex mirror. Okay, let's move towards the data. So the first thing that we know in the data, it is distance from the mirror, which is P equal to 12 centimeter. Also write in a question. After that we have a focal length of a mirror, which is if it is minus 15. Okay. After that we have a height of a candle, which is 4.5. It is already given in our data. And what is the position of image? The position of image is Q. We don't know about this, and we don't know about the nature and size of a image. Let's move towards the solution, that how we are going to solve this problem. And we have a mirror formula for that. The solution for mirrors, we already have a one formula. And what is the formula? The formula is 1 upon f is equal to 1 upon p equal to 1 upon q. Okay, we are going to put all the non-values in the formula. So when we put all the values in the formula, then we get 1 upon, here we are not aware about the q, so that's why we have f and p. So the value of f is minus 15 and the value of p is 12. Okay, then after that we have 1 upon q equal to minus 12 and minus 15. Okay, and it will be divided with 180. Then after that, when we solve it, then we minus will be plus. The sign will remain minus, but the values will be plus with each other, so that's why we get 27 upon 180. So now the denominator and numerator will change. Then we get when we divide them, then we get 6.57 centimeter. Now we have a q, which it means the image is a virtual. It is a virtual image, it is not a real image. So what is the magnification of a candle? It is and how we are going to find out it? It is m is equal to q upon p. So the q is 4.5 and the p is 4.5 and the q is 6.6. Then it will be divided with 12. Then we get 2.5 centimeter height of image. Okay, let's move towards the next one, numerical problem. It is the speed of a light in a year is 3.0 multiplied by 10 per 8 ms. So if the refractive index of our diamond is 2.4, then find the speed of a light in it. Okay, let's move towards the picture. What the numerical says to us. In this numerical we are going to find out the speed of a light in this diamond. Okay, let's move towards the data. In this data we have speed of a light in air equal to 3.0, which is already given to us in a data. 3.0 multiplied by 10 per 8. After that we have refractive index of a diamond, which is 2.42, and the speed of a light in diamond, we don't know about this. After that we are going to solve it. So the refractive index equal to speed of a light in air upon the speed of a light in a diamond. Here we have refractive index, which is already given to us. It is 2.42. And what is the speed of a light in air? It is 3 multiplied by 10 per 8. Okay, so in upon we have speed of a light in a diamond. Okay, this value we are not aware about this value, so that's why it just as it is we are going to write it. Speed of a light in a diamond, now we have 3 multiplied by 10 per 8 upon 2.42, which is the refractive index, which is equal to, when we multiply them and divide them, then we get 1.239 multiplied by 10 per 8. Okay, so it means 1.24 multiplied by 10 ms is the answer of the question. Means the speed of the light in a diamond will be 1.24. Okay, as I'm clear to you. Let's move towards the next one, numerical. In this numerical, the depth of a pond is 4 centimeter, 4 meter. What is the apparent depth of the pond if the water level is 3.5 high? The refractive index of a water is 1.37. So let's move towards the data. In this data we have depth of a pond is 4 meter and the water level is 3.5 and apparent depth we are not aware about this, and refractive index of water is already given to us, it is 1.37. So refractive index is equal to the real depth upon apparent depth. It is the formula of the refractive index. So we have refractive index of water. It is you know very well that the refractive index of each object is different from the other object. So the refractive index of water is 1.37. After that, real depth is 4 meter, and what is the apparent depth of a pool? We don't know about this. It is the question that we are going to find out it. So apparent depth equal to of the pond is equal to 2.919, and how we can say, just solve this data and then we get 2.919. Okay, I hope each and everything is clear to you. If you have any kind of a question, just ask from me, text me, and or just send the message to your coordinators. Definitely I will help you.